Welcome, fellow cosmic explorers. Today, we're delving into an intriguing discussion about the origins of the universe. Before we get started, let's set the scene. Picture four distinct images in your mind. To the top left, envisage the expansive and seemingly infinite cosmos, filled with countless galaxies, glittering stars, and mysterious cosmic phenomena. Move your gaze to the top right and envisage the awe-inspiring spiral arms of a galaxy, each arm a cradle to billions of stars and potential worlds. Down to the bottom left, visualize a close-up view of a star. This celestial furnace is where elements come to life. Lastly, on the bottom right, an artistic rendering of the Big Bang, the explosive genesis that ignited all of existence. These are the key points of our discussion today. We're covering everything from the vast expanse of the universe to the heart of a star, from the intricate layout of a galaxy to the mind-bending inception of the Big Bang. This is the arena where the grandest show ever takes place, the birth and evolution of the universe. So prepare yourselves, cosmic explorers. Our exploration into the beginnings of time and space starts now. Our first topic, the dawn of the universe. Ever considered the origin of everything? It all began with a concept incredibly small, yet incredibly vast: the singularity. This isn't just any point in the cosmos. It's a point defined by infinite density and temperature. Picture something smaller than the tip of a needle, holding the entirety of matter and energy present in the universe today. Hard to believe, isn't it? Yet, that's the beauty of our universe. It's filled with mysteries and paradoxes that test our understanding of existence. This tiny, incredibly dense point, the singularity, is said to be the birthplace of everything. Every grain of sand, every star, every galaxy, each person, everything originated from this singularity. Imagine a period when time didn't exist, place without space. Everything that would later make up the universe we love today was compressed into a singularity. Then something happened, a catalyst that still confounds us. The singularity became unstable. And then about 13.8 billion ago, the Big Bang happened. A colossal explosion from this singularity marked the birth of our universe, the moment that created everything, space, time, energy, all born from this single event. From a point smaller than what the human eye can see, the universe expanded at an unimaginable speed, faster than the speed of light. Rapid expansion, also known as cosmic inflation, is the reason for the immense, seemingly infinite universe we see today. So, when you up at the night sky, remember, you're not just observing stars and galaxies, you're looking at the remnants of a colossal explosion that occurred billions of years ago. An explosion that created everything we know and love, and an explosion that originated from a singularity, the birthplace of our universe. The Big Bang was not just an ordinary explosion, it signified the inception of something fantastic, something that surpasses human comprehension. Imagine yourself at the heart of an immense explosion, one that doesn't just disperse matter, but actually creates it. This is the Big Bang, a moment in time when the universe, as we understand it, sprang into existence. However, it's crucial to clarify that the Big Bang was not an explosion in the commonly accepted sense of the word. It wasn't a detonation set off in a specific location, spreading into pre-existing space. On the contrary, it was an explosion of space itself, a sudden and rapid expansion that gave rise to the very fabric of the universe. The universe exploded into existence from a singularity, a point of infinite density and temperature. It didn't merely appear out of thin air. It exploded into existence, evolving from something exceptionally small to something incredibly vast in less than a blink of an eye. From the smallest particles to the largest galaxies, everything we understand and everything we don't originated in this one moment. This expansion didn't occur at a leisurely pace. It was faster than a bullet, faster than the fastest spaceship, even faster than light itself. Picture, if you can, the universe as a lump of bread dough. Just as yeast causes the dough to rise and expand, so too did the energy of the bang cause the universe to enlarge. This rapid expansion, known as cosmic inflation, is a theory that helps to explain some of the universe's large-scale properties and characteristics. It is the reason the universe looks almost identical, no matter where we look. It's why the cosmic microwave background radiation, the lingering afterglow of the Big Bang, is nearly perfectly across the sky. So the next time you look up at the night sky, bear this in mind. Every star, every planet, every galaxy traces its origins back to this extraordinary event, the Big Bang, the beginning of everything. In a brief instant, the universe expanded at an unmatched speed, outpacing even the speed of. Following the Big Bang and speedy expansion, the universe was a sweltering, compact mass of particles. Yet how did these particles transform into atoms, the fundamental constituents of our universe? To unravel this, we need to dive into the cosmic timeline. After the initial blast, the universe was a roasting mix of particles and radiation. It was so hot and dense that particles of matter and antimatter would constantly create and annihilate each other. As the universe grew, it started to cool down. This cooling down phase was crucial to the transformation of atoms. Around several minutes after the Big Bang, the universe had cooled down sufficiently for protons and neutrons to bind together and transform the nuclei of the most basic elements, hydrogen and helium. Yet, these weren't atoms yet. The universe was still too warm for electrons to attach to these nuclei and form stable atoms. For nearly 400,000 years after the Big Bang, the universe kept cooling and expanding. Ultimately, it cooled to the point where electrons could at last attach to nuclei. This process, known as recombination, resulted in the formation of the first stable atoms, chiefly hydrogen, helium. These atoms were the initial building blocks of the universe. Gradually, gravity started to pull these atoms together into clouds. These clouds became denser and hotter, eventually sparking the nuclear reactions at their core, giving rise to the first stars. These stars then grouped together to form galaxies, setting the structure for the universe as we perceive it. So from a hot, dense sea of particles, the universe cooled and expanded, allowing for the transformation of atoms. These atoms then acted as the groundwork for stars and galaxies, crafting the vast cosmic panorama we witness today. The formation of the first atoms marked a critical juncture in the universe's history, leading to the genesis of everything we see around us today. From the first atoms came the formation of the nebulae, which were created by atoms clumping together under the influence of gravity. These nebulae were not just immense cosmic clouds. Within them, something fascinating was occurring. As the gas and dust clouds within these nebulae were condensed by gravitational pull, protostars, precursors of stars, began to form. But how does a protostar become a star? The core of these astronomical bodies holds the answer. Here, the temperature and pressure reach such heights that hydrogen atoms begin to merge, creating helium through a process known as nuclear fusion. This fusion process releases a vast amount of energy, causing the star to radiate intensely. This is how the transformation of a protostar into a star happens. Concurrently, as stars were forming, another event was happening on a grander scale, the formation of galaxies, massive structures that house billions of stars. As with the atoms that formed stars, gravitational force played a key role in the creation of galaxies. Stars started to attract each other, forming clusters. Over time, these clusters merged to form larger structures, which eventually evolved into galaxies. Some galaxies are spiral, such as our own Milky Way, while others are elliptical or even irregular. The whole process is as intricate as captivating. From the first atom to the vast galaxies, each stage stands testament to the awe-inspiring power of nature and the laws that govern our universe. Over billions of years, these atoms, stars, and galaxies have shaped the universe as we know it today. From a singularity to a sprawling expanse abundant with galaxies, stars, and planets, the universe has been on an awe-inspiring journey. This cosmic journey kicked off with an ignition, the Big Bang, and has been perpetually evolving since that epoch. Covering an impressive span of over 13.8 billion years, this journey brought forth a multitude of stars, galaxies, and even life itself. From the creation of the earliest atoms in the universe's primeval broth. During its early days, To the genesis of stars and galaxies, the universe has been an endless cradle of creation. And the universe we observe today is an impressive tapestry, intricately woven with threads of stars, galaxies, and cosmic dust. Each thread represents the universe's journey from a singularity to its current form. However, this journey is nowhere close to its culmination. The universe continues in its progression and evolution. It's not static, but expanding. Yes, you heard it right. The universe is growing. With every tick of the second, minute, hour, galaxies are distancing themselves from each other, increasing the universe's size from the previous moment. And it's not just about the size. The universe continues to progress. Stars continue their life cycle of birth and death, galaxies clash and merge, and new heavenly bodies take form from the cosmic dust. The universe as we understand it is a dynamic, continually changing entity. The universe's journey from a singularity to its current form bears witness to the power of creation and evolution. It's a journey that has offered us a dwelling, a standing in the cosmos, and a perspective on existence. The story of the universe is a tale of creation, expansion, and evolution, a saga that is still unraveling even today.